Good morning to all of you. It is audible to you? Audible? Right, voice is clear. Okay, right now. The last, just I will go for the summary of the units. So thereby you can get somewhat understand. So what is the step by step in this? Actually, the contents in the mechatronics syllabus, what it is very beautiful. So step by step it is given very clearly. So I will explain you from the unit one onwards. Just I will go for a brief summary. What you studied in unit one to up to unit five. Lastly, we are going to unit six, right? So see in this first unit one, what we discussed about a mechatronic system, right? And the brief scenario of unit one, uh, we discussed about the various sensors and transducers. That is, various sensors and transducers means like displacement, position, proximity, velocity, motion, acceleration, torque, fluid pressure, liquid flow, liquid level, and temperature measurement devices like thermocouple, RTD, thermistor, and light sensors. So these are there are several sensors are there, but we discussed some of the sensors as per in the syllabus. That is some of the sensors. The next we discussed in the unit one about the mechatronics design process. It's very very important. Even JNTU Kakinada end semester examination. And we discussed the elements. What are the key elements in mechatronics? What are the levels in autumn mechatronics? And advantages and disadvantages in mechatronics? And types of control systems, classification, open loop control system, closed loop control system, and microprocessor based controllers. Actually, in unit one, the brief scenario we discussed what is mechatronics, what are the levels, what are the elements, what for a design process, what is a mechatronics design. So in the design process, here apart from this, we are discussed about the various sensors and transistors. That is the unit one level. And in unit two, we discussed about solid state electronic devices, various devices of electronic devices. So in the syllabus, it is about diode, BJT, bipolar junction transistor, field effect transistor, diac, triac switches, LED light emitting diode, analog signal conditioning. Actually, this analog signal conditioning, it is also there in the unit 5. Analog signal conditioning, operational amplifiers, noise reduction, filters. So these are the parts, components, sorry, that we components or devices, electronic devices we studied in Unit 2. So why here in Unit 2, a mechatronics is nothing but it is mingled with mechanical, electrical and electronics and computer based information system. So here in the first unit one, we studied about various sensors and transducers. In the second unit, we studied about solid the electronic components. So that means here your total completely you are getting awareness about the sensors and electronic components. So these sensors and electronic components mingled in a mechatronics system or a product. So one thing, and the next, the third unit, what we discussed, this is actuation system. What is the actuation system? Sir, I will give just a mapping of all these 5 units one by one. And unit three, hydraulic and pneumatic actuation system. I think actuation system means a system is actuating to get our required output. So it may be the medium is hydraulic and the medium is pneumatic. So in this, we studied about in Unit 3, hydraulic and pneumatic actuation system, fluid systems, hydraulic system first, and pneumatic systems. So in this, we discussed various components, and also types of valves, control valves. So pneumatic control valves, hydraulic control valves. Already you performed in the experiments, some of the experiments, and electro pneumatic and electro hydraulic servo systems, mechanical actuating systems, electrical actuating systems. I think all why we have to go for actuation system. I told to you clearly in the unit. See, why we have to go for shifted to mechatronics from the mechanical to mechatronics. See here, in this mechanical, we are having the mechanical actuation system to go for mechanical actuation system. So to get our output, we are having some mechanisms, right? Cams and followers, right? Cams and various types of mechanisms already we discussed. So to eliminate all the things with the help of these hydraulic and pneumatic systems, we can get the output. Now you got the clear. These to implement the hydraulic and pneumatic actuation system with the help of some electronic devices like solenoid, valves, sensors, non-contact type of sensors, proximity, like this example. So why is here in the olden days mechanical actuation system to get our output? Some mechanisms are there, some linkages are there. So about the so to replace all the things, we have to go for hydraulic and pneumatic actuation system to get our output by the medium of either hydraulic or pneumatic. That means air or a liquid. So now, so we have to replace the so for example gear mechanism, right? So gear, so to replace all the things, and for example, electrical actuation systems, motors, running of motors, we have to replace all the things. From the motor, what we are getting some output energy, right? So this output energy, with the help of the hydraulic and pneumatic actuation, we can get the with the help of the air. For example, pneumatic, if you take pneumatic compressed air, actually it is some of the energy to get the output, to get out, right? So like this, see here, uh, this, so whatever the mechanical actuation system link, that means in other words, there are so many are there. Uh, so just wait. I have to say already we discussed it. There, 1 minute. Give 1 minute. You have to please give 1 minute to me time. Right. So here in this, that means whatever the motion converter, that is the transformation of the motion from one form to the another form, maybe that a linear to rotational, and the mechanical elements, that means like linkages, cams, gears, rack and pinions, chain drives, belt drives, these are all we can replace. So can and then we have to by replaced by hydraulic and pneumatic actuation systems. So in this hydraulic and actuation systems, we are having the components, electronic component, that means sensors, and the solenoid is the electrical component, like this. So that component, so we are going to study it here in this unit, in particular in this one. Right, and then next if you go for further, uh, the unit 3, that is the what, that is a semi, you can call it as a semi automatic in unit 3, that is electro hydraulic actuation system, electro pneumatic actuation system. That means the electro means electronics involved in the hydraulic actuation by replacing the old mechanisms. So that is that semi-actuation, semi-automatic. These electric, that is these hydraulic and pneumatic actuation systems are semi-automatic systems, right? So this is very very beautiful unit. Nowadays, almost all large scale industries or small scale industries, these actuation systems are there to activate or to that means motion, convert the motion. Even the robotic gripping device is also with the help of the pneumatic actuation systems. Gripping, holding device. And in Unit 4, if you come to Unit 4, Unit 4, what we learned about the digital electronics and systems. So digital logic controller in this microprocessor, we discussed about 8051 microprocessor, microcontrollers, programming, and PLC is one of the best software. Here, what we discussed in Unit 3, it is a semi-automatic system. This will be fully automatic with the help of this PLC, programmable logical controller. So here it is Unit 4, with the help of the PLC, we can go for whatever the Unit 3 we discussed. That Unit 3 is semi-automatic, that hydraulic and pneumatic system. With the help of the PLC, we have to make it fully automatic, programmable logical controller. So actually that programmable logical controller we will go for fully automatic. Whereas what we discussed in the lab, mechatronics lab, that is automation studio software already you learned. That is also what we are it's a simple experiment. So you learned about the actuation of single acting cylinder, double acting cylinder. We have to draw a circuit diagram of that whatever single acting cylinder, double acting cylinder. So that circuit diagram we will use the output. It will use the output, right? So that means we have to connect in that particular software, maybe either a PLC ladder diagram, logic ladder diagram. That is also there. Your program is also there, and then that is also in two modules are there. This fully automation system in the lab. One is PLC, another one is automation studio software, right? So in this, whatever hydraulic and pneumatic actuation system, you have to draw connections correctly, and then we have to go for simulation. Whatever the output, if it is correct, then we have to go for fed to the real system. So then automatically we can get the output. That means Unit 3 is semi-automatic, and Unit 4, what we discussed, this is fully automatic, which is linked with the Unit 3 and Unit 4. And also we discussed in Unit 4 what I said, some microprocessor, right? A microprocessor and microcontrollers. Microprocessor 8051, right? This is a purely computer-based information system. We can get that this Unit 4, what you learned, microprocessor, that is linked with Unit 5. That is linked with Unit 5. And if you go for Unit 5, system and interfacing and data acquisition, right? And the data acquisition system, what I told to you that some sensors and transducers here, overall picture, I will tell you, right? So now, in the Unit 6, you can get the Unit 6. And Unit 4, we discuss Unit 5, we discuss data acquisition system. The data acquisition system, what are their signal conditioning, A to D converter and D to A converter, right? And then digital signal processing. Here, the in between A to D and D to A, we are going processing the signal is processing. So that one we studied. So to get our output in an optimized level. And then in Unit 6, it is a dynamic model and analysis. So now, in the Unit 6, we are going for dynamic model. Before a prototype model, we have to go for dynamic model and analysis. So, for example, a system is there. In the system, to input is there, and then we'll get the output. So, right. So, system and some system output and input is there, right? All of you know that. So in this, if the output is not our desired output, what we have to do to get our required output, we have to send with the help of the sensors and transducers You have to send some feedback element again to the input, right? And then this input with the help of the sensors and transducers, what you studied in the unit 1, right? That, and the next step we have to go for the next unit 2, whatever the signal conditioning, right? Analog signal conditioning, and we have to use various amplifiers and filters to overcome that error. And then next we have to go for what you studied in unit 4, like data, that is microprocessor. And the next we have to go for unit 5, that is what you studied in data acquisition system, right? That is analog signal conditioning. That means A to D converter and D to A converter again we have to give to the system. So these are all the things I given in clear picture in the flow chart. So these are all the units mingle. We can get the last unit 4, unit 6. Unit 6. Here, dynamic models. Dynamic models. I said dynamic model means a model that is a prototype or analytical modeling. Prototype model. We have to analyze analogies. What is a dynamic system and analogies? Here, as you can see, dynamic model and analogies. Analogies means here we have to compare with one system to another. So first we have to go for sir, what you studied in these 5 units, you have to prepare with the help of that knowledge. So next I have to give one by one. Next class I will ask you, right? So with the help of what you studied all the things, we have to make a model, dynamic model, and then we have to compare with that system to the other system. That means comparison means here we are comparing the output. So this dynamic model. So with the help of 5 units, what you studied, sensors and transducers, electronic components, actuation system, and digital electronic devices, and the next data acquisition system for one software, PLC software. These are all the things, right? So according to our require whatever the product, that one first we have to go for dynamic model, and then we have to go for analogies and all. That means comparison. So that is this one we are putting incorporating in this. In other words, we are going for designing a mechatronics product by taking whatever the fundamentals what you studied from the unit 1 to unit 5, right? Mechatronics, a product model. That is just a model, one model, dynamic model. What is the model here? A mechatronics product. Take a mechatronics product, washing machine. Next class, I'm asking about the washing machine, right? The washing machine, just there are so many components are there. So what you studied in the previous, that one we have to go for. We have to go for a model, flowchart model, and then we have go for we have to comparison with the output. What we have to give the input and what we have to get the output. So right. So washing machine like that. There are these are the models. Here, washing machine is one of the model, right? Who will right? The next, if you go for the next dynamic models, system response. How can you system response? You give the response of T like that. And the next, process controllers. Already we discussed the process controllers also. Various industrial, in the industry you can go for various process controllers. Already we discussed this one in unit 3 or unit 2. And the digital controllers. These process controllers in industry and digital controllers, in that we have to go for developing a model. That means design, development, and a prototype. So this design is nothing model development, prototype development, and prototype. And see here again in this repetition is there programmable logical controllers. Here three controllers. One is process controllers, digital controllers, programmable logical controllers. So these are all used for completely fully automation only by the replacement of the olden whatever the things in the mechanical actuation system and the design of a mechatronic systems and future trends. So in this here in the design of a mechatronics system, if you see here design of mechatronic system and future trends, we have to go for develop a model of a mechatronics system, design and development of a mechatronic system. Actually, my MTech project is a design and a development of a lifting system. Here, the lifting system is also a mechatronics system, lifting system, design and development of mechatronics. Same here also in the syllabus it is given that design of mechatronic system according to our requirements and considerations. We have to design and develop a mechatronics product. That means product. Four or five examples and future trends. Right, we'll discuss. This is the complete of a unit 6. And I'll go for the next unit. Next slide. See here in this, what I said to you, dynamic models and analysis means a design, development, and then we have to go for a modification. We have to go for modification also. Why we have to go for more modification? If there is any defects or if the output is not reachable output, then again we have to go for modification. And control. Control is very important. So here this control is automatic control. Here to regulate the output according to the inputs, to regulate the output according to our given inputs. So mechatronic system require an understanding and suitable representation. So here we have to give a suitable representation. So that is called a dynamic model. That is called a dynamic model. So here it's a design, development, modification, and control of a mechatronics product. This product require an understanding. What is understanding? A suitable representation. That representation we will discuss in examples with, right, of the, and this is called a dynamic model. This one is called a dynamic model, right? System model. You can also call it a system model. So this model is an idealization of the actual system. It should be like an idealization of that. What I said to you, analogies means we have to compare with the actual. We have to compare whatever you designed and developed. That one we have to compare it with the idealization of the actual system. So any model, see here, any model should be, we have to compare. It should be comparison with the idealization of actual system. The properties established and the results are derived and associated with the model rather than the actual system. Whereas the expectations are applied to and output responses are measured from the actual system. Here, the output responses should be whatever you are having some output. So for an actual system, it should be like that. So that should be excitation. So you can get the output with the whatever in the dynamic model. So the output should be reachable. The next, see if you clearly observe, see here in this, here a mechatronic system may consist of several different types of components, what we discussed from unit 1 onwards. And it is termed as a mixed system. What I told to you that mechanical system, mechanical or some other machine or some other system it is this mixed with several components. What you learned in the previous units, it may be electronic devices, or it may be sensors and transducers, or it may be converters, or it may be amplifiers or filters, right? Some control valves, electronic control valves, and switches. So these are all coming under the mixing of components in these mechatronics flavors. Different types of flavors, what we discussed, that should be mixed in the mechatronics prototype systems. It is useful then to use analogous procedure for modeling such components in this manner. The components model can be conveniently integrated with the to obtain the overall models. Means integrated means these are all integrated to obtain a overall mechatronics product model. If you observe, see here. Then here in particular analytical models, there is here what I said, here some models are there. I will discuss in the next slide. So here the analytical models, here we developed the mechanical, electrical, maybe developed fluid and thermal systems rather analogous manner, because some clear analogies are present among these four type of systems. In view of the analogy, then a unified approach may be adopted in the analysis, design, and control of mechatronics. Means here an analytical model, that means analysis. Maybe the system is developed in mechanical, electrical, fluid, and thermal system. But in view of analogy means comparison, that we have to adapt. In mechatronics product also, we have to adapt that analysis also. Analysis means, for example, if you take a system is there, for example, take our for example, thermal four-stroke diesel engine, or four-stroke petrol engine, or air compressor testing. Just what we are doing, we are performing experiments. So by giving whatever the inputs we have to set, and then we can get the output. In output is some physical parameters, right? So this is one we have to go for analysis model, which is mingled with mechatronics. We can get the output in the form of the graphs. For example, what we have to do in four-stroke diesel engine, we have to calculate the performance, right? Brake thermal efficiency, mechanical efficiency, volumetric efficiency, with the help of the some mathematical formulas. So not required nowadays. Now day by day, the technology is developing. So no need of go for calculations. Just we have to go for it is mingled with the computerized, and then we can get the outputs in the form of graphs. Even you are taking the graphs, right? So x-axis and y-axis, brake power or load on x-axis, and y-axis maybe about the brake thermal efficiency or mechanical efficiency or some other parameter, specific fuel consumption, like that, right? So we can get the output directly with the values by taking the printout. It is analysis. These are the so actually in the analysis, what we have to go for? We have to go for calculation. But here in this mechatronics mingled with electronics, digital electronics, we can get the output in the form of printout directly. Even if you go for combustion analysis or exhaust gas analyzer, I see here our exhaust gas analyzer, we can get the output in the form of directly in the monitor. We have to take down the values, right? Or even in the combustion analysis also, the crank angle versus pressure rise. Crank angle versus pressure rise. So like this. And see here, dynamic model. See here, if you go for this here, what I showed to you, that models, right? Here, physical models, that is prototypes, analytical model, that is analysis. You can go for analysis. So one is a prototype model. For example, take the 3D printing. If you give the input, we can get the output. model, whatever, for example, pen stand or some other product, glass, right? Glass tumbler. We can manufacture. These are the prototypes, 3D printing. But analytical models means what I said now, that we can get the output in the form of a graph. And computer numerical models. What is CNC, computer numerical? So here we have to write a program and then we have to fed. Even 3D printing also same. 3D printing also we have to go for a modeling and design, and then we have to go for simulation or analysis. Then again we have to go for fed to the system. These are the computer numerical models. Those are computer and the experimental models, input and experimental data. What I said, the exhaust gas analyzer. See here the input, if you take here the exhaust gas will be take, we can get the output, that experiment data, carbon dioxide, how much percentage, carbon monoxide, how much percentage, like that. Even nowadays, it is development is very high. Actually, in our lab, we are taking just time in seconds. For example, four-stroke diesel engine. What we are going for, you are taking the YouTube that is a manometer. You are finding out the levels H1 and H2 and the time, right? Time taken for this much amount of level of fuel consumption, right or wrong? Time is the input parameter and H1, H2. With the help of these values, you are calculating all the things. Nowadays, not required. These experimental models, what are the fourth one, using input slash output experimental data, we can get the output directly. In the monitor, it will display how much brake thermal efficiency, for how much load, how much brake power. So load, quarter load or full load or half load, like that. For half load, how much brake thermal efficiency? Actually, what we have to give in the manual, what we are doing, we have to set the speed with a particular speed, 1500 RPM, and then we have to give load either 1 kg or 2 kg. And then next in the YouTube manometer, we have to find out the H1, H2 level, and the next how much time taken for the this much amount of fuel consumption for 10 centimeters, like that. So this nowadays it is not go for directly. We can get the output which is displayed in the monitor. So all this is what I said. This is the experimental models. What I said, this is experimental. Here total 4 types of models are there. These models we have to develop in such a way that what you studied in the previous 5 units. Right? Now you got the clear picture about. So this one we are going to develop just a model, dynamic model, right? Huh? Tomorrow we will discuss, right? And also system response. System next class we will discuss about system response and process controllers, and the next PLC. Next we will go for the mechatronics product. Okay, any questions? Right, any questions? So now respond attendance one by one. One minute to respond one by one. So great. Number 1, 4, 5, 7, 8, 9, 9, 9. Number 9, 10, 10, 11, 13, 14, 15, 16, 16, 17, 18, uh, 18, 19, 20, right? 21, 22, 23, 24, 25, 25, 26, 27, 28, 28. All right, 29, 30, 29 option. 31, 32, 33, 33, 33 option. 33, okay, right. 33, okay. Next, 35, 35, 36, 37, 38, 37. 37 option. Okay. 39, 39, 41, 42, 43, 43, 44, right. 45, 46, 45, 45 option. 47, 48, 48 option. Right, 49 present, right. 40, 40, 45 option kadamma. 49, 50, 52, 52, 54, 55, 56, right, 54, 60, 61, 63, 61 Nana, absent. 63, 64, 65, 66, 67, 68, 68, right, 69, 69, right, 70, right, right, 73, right, 74, 74, 75, 76, 77, 78, 79, 80, right, 81, 81, right, 83, right, 84, 85, 85, 86, 88, 89, 89, 90, 91, 92, 92, right, lateral tree 1, 2, 3, 4, 5, 6, 8, 8, 9, 10, 11, 11, right, 11 option, 12, 13, 14, 15, 15, 15 option, 16, right, 17, 18, 20, 21, 23, 23, 24, 25, 26, right, 27, 28, 27, 27 option, 28, 29, 30, 31, 32, 33, 32 option, 34, 35, 36, 37, 38, 39, 40, 41, 43, 41, 43, 41 option. Okay, right. See here, these are the option keys: 5, 7, 10, 11, 18, 29, 37, 45, 61, 63, 64, 65, 66, 67, 69, 74, 76, 78, 85, 89. Lateral entry 11, 15, 23, 27, 30, 32, 34, 36. Correct? And 45, okay. 10th batch 341, okay. Okay, no. 89, okay. Next. Anybody else? Okay. Anybody else? That's on to 30. 13 already present. Already present, already you responded in the beginning. Okay, right. Thank you all of you. 85. Okay, thank you all of you.